Hello, you're welcome once again to day 12 of Talking to the Camera Challenge. So yesterday I talked about blockchain technology, and one thing that I noticed that my audience, some of them may not understand, not fully comprehend blockchain technology. And I thought it wise to maybe why don't I explain it. And this is my attempt of simplifying blockchain to anybody who may not understand, doesn't have a tech background, as simplified as possible what blockchain technology is. So if it's you and you think you really want to understand this, let's start. I'm called Otim Frederick. I'm going to explain the technology using an analogy of a notebook. Let's say this is a unique notebook. To preface this, we've all used Word document. Might have been a Microsoft Word that you downloaded onto your phone. It could be on your computer, or you used it online using either Google Docs. But this one here is a notebook similar of the kind. Let's say you will start off on a blank slate, open a new page, and so that is our technology there. Now the core pillars of blockchain technologies, there are around three things. One, it can be shared with everyone. Two, anyone can write to it and read from it, but they are unable to delete or change anything they've written to. And then three, it is encrypted, it is locked somewhere securely by a unique encryption standard. So that is the core premise where it operates with. So let's unpack this. Now let's say to our notebook, you start off on a blank slate. This notebook, the purpose for it is to just record transactions of every note that you do. But when you've written your notes, and when you're done, it captures that. And when you say you're done, and it saves it, and you will not go back and change that. What you will do is you'll create a new page. You go to a new slate, and you write another message, and it will save it. However, it will connect the first one that you wrote with the second one. Instead of keeping now this notebook by yourself, maybe on your phone or on your computer, it is distributed to different computers across the globe. Let's say here in Uganda, in the UK, the US, Asia, in India. It's distributed to those people. All these people have a copy of this notebook that we are talking about, our unique notebook. These people who have it, they are able to write to that notebook. When you write onto this notebook and you save, it is immediately recorded. When it is recorded, it is encrypted to a point where you cannot go back and change it. What you can do is create a new page to write your information. Now let's take it step by step. Let's say me or Tim Frederick, I want to send money to say John. In order for me to send this money, let's say $10, I have to tell people in these networks who are in Uganda, distributed across the world. I'll broadcast it using the technology. I will not literally broadcast it, but when I come to say I want to send this money, the technology will distribute this information. It will tell people in these different networks that our team wants to send money to John, and the different people will have to come through and say, okay, our team, someone in India will say, our team wants to send money to John. And also someone in the US will say, our team wants to send money to John. Now, a collection of those people, it's called a block. Once we are past that, now it has to be verified that, okay, so the technology has to verify that, or team, do you have the $10 that you want to send to John? If it verifies that actually our team has the $10, then it says, okay, we can now accept you. That entire block will be like, okay, we're adding you onto the network. Now, when it is just at the beginning, at the start, maybe you are starting this notebook at the beginning, it is fresh, it is blank. It will create a unique encryption of the details of that information and give you a unique hash, a unique information, which is called a hash. The next time I come, maybe someone else also wrote to this network, and now it is not my initial thing that I started was added. So let's say it's now the second time. Now for that second time, when someone is adding onto this network, what it does, it encrypts, it locks the information that you're trying to send, the details, some of those details. It gets that together with my initial information that I put and connects it together, and it becomes a chain of locks, which gives the name blockchain. You may ask now, how about a hacker? What if he comes in between? Can this thing be vulnerable? Yes, that's true. Let's say now, from the explanation of the block information being added onto each other, and they're encrypted, and in order for a block to be added to each other, it gets the unique ID of the previous one which was added, and then it adds on to this. Now when the hacker tries to change, let's say, okay, I didn't send him $10, but I sent him $100. Now what it will do, it will change the information because it is connected one to the other. It means this is now new information that it will attach itself to, and then the network will read and say, okay, it is not adding up the previous information with this other one. It changes the connection and with the current one, and it will break the connection because the unique ID of what I created for the $10 won't match the unique ID of the new attacker who says I've sent $100. Now if the attacker claims like no, it's still true, he has to convince all the computers which are distributed across the world and say, okay, Tim Frederick sent me $100 in the UK, in the US, India, all of it. Has to be able to have that capacity to send this information at the same time, which is practically impossible. The key takeaway is this: a blockchain is more or less like a store of information, which is a database, which is distributed across the world, making it decentralized. That's one. And it is not controlled by a central authority, let's say a bank, a company, or a country. The people participating in this network are the ones who control this. Then two, the network is transparent and verifiable. Anyone can come and check and verify the transaction which has been made. And then three, it is immutable. By immutable, it just means it cannot be changed. Once the information is recorded there, it's practically impossible to undo that. So what is blockchain used for, if you may ask? Blockchain has so many use cases actually. One, in digital identity, self-sovereign identity. And let's say refugees, it is hard to track refugees and citizens, so we get the unique ID. Two, it's helping in financial inclusion, such as cross-border payments, lending and borrowing. Three, supply chain. This helps in traceability and provenance. For example, you can track products from farmer to the plate. In the creative economy, it has facilitated digital ownership and assets, such as NFTs, non-fungible tokens, and tokenization, which is the fractional ownership of real-world assets. I think it's like 5, in the healthcare, secure health records. Personal health information is really important, and blockchain ensures that it's encrypted and no one can read it. You can give this access to someone or revoke it. Actually, it enables this. And intellectual property. Now, lastly, now this is a simple framework in assessing a use case of a blockchain. You need to ask a simple question: what are some of the problems that requires a middleman, or there is no trust there, or you need a level of transparency? If those problems are facing those challenges and it's a pressing need, that's when you use the blockchain technology. That's it, guys, for today. I hope maybe you got some value and maybe you followed along. If you've gone this far, thank you. I've tried explaining it the high level as possible without getting into the details of the blockchain. What is blockchain? Thank you, guys. Until the next one. Cheers.